2.6 quadratic formula. This should be review. Here's my quadratic formula over here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, this division is basically the last thing that you do when you're dividing everything by the product, the quantity of 2a. The quadratic formula only works when you're equal to 0. If your quadratic isn't equal to 0, it's not going to work, just like with factoring, with graphing, finding the roots by setting it equal to 0. So here, I have an a value of negative 3, b is negative 5, and c is 8. So I can do x equals negative b would be positive 5 plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2a. If I keep going here, hopefully you understand that negative 5 squared is actually positive 25, not negative 25. If in your calculator you do negative 5 squared without parentheses, your calculator will tell you negative 25, because your calculator does the 5 squared first, and then makes it negative. You want to, in parentheses, do negative 5 squared to get positive 25. It's very hard to overuse parentheses on your calculator, but hopefully you just know that negative 5 squared is 25 without your calculator. Now, negative 4 times negative 3 is positive 12. Positive 12 times 8 is positive 106. No, sorry, positive 96. I'm going to put that over 2a, which is negative 6. Well, 25 plus 96 is 121. And that's still over negative 6. The square root of 121 is 11. 5 plus 11 is 16, so I do 5 plus 11 over 6, which is 16 over 6, which is 8 over 3. These should be negative, so it's negative 8 over 3. And I do 5 minus 11 over 6, which is negative 6 over negative 6, which is positive 1. So my solutions are negative 8 over 3 and positive 1. If you want to do this on your calculator, that's not too bad. You just got to be very careful with your parentheses. I'm going to take all of this stuff and type it into my calculator as it is. But I have to start with a parenthesis, because everything on top I really want to have in parentheses up here. So I do 5 plus the square root of, in parentheses, negative 5 squared. I could just put 5 squared there. I usually do just put a positive 5 squared, because it becomes 25 anyways. Minus 4 times negative 3 times 8. And then I need to close 2 more parentheses here. Let me check to make sure that's right. I have 1, 2, 3, 4, 5, 6 open parentheses. So I need to have 1, 2, 3, 4, 5, 6 closed parentheses. And I divide that by in parentheses. This negative 6 is also going to be in parentheses, that matters. So I get this, negative 2.66666, which is what this right here was. If you wanted to make that a fraction, you of course could. Math arrow frac, and there's negative 8/3. And the nice thing about typing it in this way is if I press second enter, I can pull up my previous equation, which was the answer fraction. If I do second enter again, I can keep scrolling through previous stuff that I entered. And now I can just go over here to where I had that plus and change it to a minus. And get my other one was 1, which was this answer here. So that's how you can do it on your calculator if you're so inclined. If you want to learn to program the quadratic formula on your calculator, I would be okay with that. We can talk about that later. The discriminant is the last little piece that we'll talk about. The discriminant is if I take the whole quadratic formula and just grab the b squared minus 4ac. That's what we call the discriminant. The discriminant tells you very useful things about your quadratic. If the discriminant, oh, and remember, discriminant is not determinant. Determinant was a matrix thing, so don't confuse those things. If the discriminant comes out to a positive number, if I calculate b squared minus 4ac, it's bigger than 0, it's positive. That means there'd be 2 real solutions. If I calculate b squared minus 4ac and it equals 0, that means there's 1 real solution. And if it comes out negative, And there's no real solutions, there's two imaginary solutions. So let me show you how that works. Here, the a value is 3, the b value is 4, the c value is 5. So b squared minus 4ac is really going to be 16 minus 4 times 3 times 5, which is 16 minus 60, which is something negative. I don't really care what it is, I just know that it's negative. I mean, it's negative 44. But this means that there are no real solutions. The solutions are going to be imaginary. If I wanted to find them, I could still do the quadratic formula, and the nice thing is I've already calculated the stuff that goes in the square root, so I could have this, which will become negative 4 plus or minus 44, can break down into 4 and 11, and 4 is 2 2s, so a 2 comes out. So this is going to be 2I root 11 over 6. And that can all divide by 2, so I can do negative 2 plus or minus I root 11 over 3. Those are my solutions if I want to find the imaginary solutions. But just doing the discriminant tells me that there aren't going to be any real solutions, because the discriminant came out negative. What am I doing for time here? Yeah, let's do a couple more examples. So if I want to find how many solutions there are based on the discriminant. A is 2, B is 4, C is 2. B squared minus 4ac becomes 16 minus 4 times 2 times 2, which is 16 minus 16, which is 0. This has one real solution. Something funny over there, Harrison? You laughing about something? Something math funny? Is that what you're saying?
No.
Interesting. So, again, if I wanted to, I could do the quadratic formula and find this, negative 4 plus or minus the square root of 0, because this came out to a 0 all over 2a. Well, because it's plus or minus 0, that's really just negative 4 over 4, which means that my solution to this problem is just x equals negative 1. Finally here, I need this to be equal to 0 always, so I get that x squared minus 10 equals 0. So b squared minus 4ac, well, my b value is 0. So it's 0 squared minus 4 times 1 times negative 10, which is 40. This has two real solutions. Great, thank you. Have a wonderful day.